In this podcast, I'm going to cover questions 5 through 10 of your solutions packet and where it pertains to solution concentration. All right, so first off, it says how many grams of barium chloride would you need to make 125 mils of water? You add 125 mils of water to make a 0.05 molal solution. All right, molal just means molality. So basically what we're looking for is we are looking for the moles, and then we'll convert it to grams. So molality is equal to moles of solute, which we don't know, over the kilograms of solution. Well, we know that the density of water is 1 gram per milliliter, so we're just going to assume that we have 125 grams here of water, which is 0.125 kilograms. Okay, so we're going to put 125 on the bottom. All right, and then if we do 0.05 times 0.125, that gives us 0.00625 moles of beryllium chloride. So 0.00625. All right, now we need to multiply by the molar mass and to get this to grams. All right, well, beryllium chloride is an ionic compound. Remember that beryllium has a 2+ charge, chlorine has a 1-. So the formula for beryllium chloride is BeCl2. Okay, so we need to do Be, which is 9.01 times plus, let's see, 35.453, that's chlorine, times 2. So our molar mass is 79.916. Okay, so we're going to multiply that. All right, and I'm setting it up this way because we had moles on top. Okay, moles on bottom to cancel. Okay, go ahead and plug that in the calculator, and I get an answer of 0.5. So 0.5 grams of beryllium chloride. All right, this one, talking about ethanol, says that we have how many grams of ethanol should be mixed with 225 mils of water to make a 4.5% mixture. Okay, well, we know we have a 4.5% mixture, and we're looking for our solute because mass percent is just grams of solute over grams of the solution. All right, we know that water is 225 grams a milliliter, so we're going to go ahead and put 225 grams on bottom, plus we have to do our solute. So this is our solvent. Now we have to add in the solute to get the solution, and all that's times 100. Okay, so we're going to go ahead and divide by 100, and we get 0.045 is equal to x over 225 plus x. All right, we need to get this off the bottom, so we're going to cross multiply this whole denominator up, and we're going to distribute that into both of them. Okay, so we get 0.045 times 225, so that's 10.125, so 10.125 plus 0.045 x equals x. Okay, we get x's on the same side, so I'm going to subtract the 0.045 to the other side, and that leaves me with 0.955 x and that is still equal to my 10.125. Now I'm going to divide by 0.955 on both sides to get x by itself. And that gives me my answer of 10.6 grams. Okay. All right, I'm going to switch colors here so it doesn't all run together in a minute. Haha. All right, so how many grams of salt are present in 13.5 grams of a 2.56 gram or 2.56 2.56% solution. So same thing, we know that we have, all right, so this is our percentage here. We know that percentage, mass percent, is mass of the solute, which we don't know, over the total mass. And it told us our total mass was 13.5 grams. And then that's times 100, right? So divide by 100, you get 0.0256 is equal to x over 13.5. I hate it when I drag my pen like that. All right, then we're going to cross multiply that 13.5 up, and that's going to tell us what our x is equal to. All right, so 0.3456 is what x is equal to. Okay, all right. Number 8, explain how to make at least 1 liter. Well, 1 liter is 1,000 milliliters, and 1,000 milliliters is 1,000 grams. And we know if we converted 1,000 grams to kilograms, that'd be 1 kilogram. Okay, I'm worrying about kilograms because I saw this little word molal, and I know that molal means molality, so I'm going to have kilograms of the solution on the bottom. So if I want a 1.25 molal solution of ammonium hydroxide that makes a liter, well, a liter is 1 kilogram. Working with ones on this problem makes our life way easier because it means we don't have to convert anything. So basically, what you need is you need to dissolve 1.25 moles of ammonium hydroxide in 1 kilogram or 1 liter of water. And that's exactly how you would make a 1.25 molal solution. All right, number 9. What's the molarity of a solution in which 0.45 grams of sodium nitrate are dissolved in 265 milliliters of solution? All right, now, molarity is moles over liters, so first we need to get this to moles. Got to know the formula for sodium nitrate. It's just NaNO3. So we're going to go ahead and figure out the molar mass. So we got 22.9 plus 14.007 plus 16 times 3. All right, so our molar mass is 84.907. So we got this divided by 84.907. All right, and that's going to give us our moles of sodium nitrate. So let's go ahead and plug that one in the calculator. So 0.0053 is our moles. All right, so that's going to be the top part of the solution. All right, now we just got to know the liters of water. All right, we know that 265 milliliters. Okay, we know that. All we have to do is move our little decimal over to get to liters, so it's really 0.265 liters. Okay, divide and we will get the molarity. So 0.0053 divided by 0.265, and molarity is 0.02. So 0.02 molar. All right, and last question, mole fraction of sulfuric acid in a solution made by adding 3.4 grams of sulfuric acid to 3,500 milliliters of water. We got to know the formula for sulfuric acid. It is H2SO4. Okay, and we have 3.4 grams of sulfuric acid. Got to get it to moles, so let's go ahead and calculate our molar mass. So we're going to do 1.0079 times 2, that's hydrogen, plus sulfur, which is 32.065, okay, plus 16 times 4 for oxygen. So 98.0808 is the molar mass. So we're going to divide here. Okay, and that's going to give us our moles. So we're going to do 3.4 divided by that molar mass, and we get 0.035. So that's the top part of the mole fraction. All right, and then we've got to do this 3,500 milliliters. Well, we know it's water, so it's really like 3,500 grams, right? And then we could just divide by the molar mass of water, which is 18.0158, and that would give us the moles of water. So 3,500 divided by 18.0158. So we have 194.27 moles of water. Okay, now we know that mole fraction is the total solution, so we have to add this and this together. So we're going to add 0.035 onto that. We get 194.31. All right, and then divide, and that will give us our mole fraction of sulfuric acid in water. All right, when I divided, I got 1.8 times 10 to the negative, let's see, 1, 2, 3, 4, negative 4th. Okay, and that's mole fraction. Mole fraction does not have any units.